Hey guys, welcome back to my YouTube channel. Today, I'm going to be showing you how to memorize the special trig ratios for the special angles. I know memorizing can be hard. I'm going to show you how to basically memorize it the easy way. Like, you basically only need to know really these two shapes, okay? This square right here and this triangle right here, and also the dimensions for it. So the square right here, each side is going to be equal to 1 unit, right? So 1 unit here and 1 unit here, right? And you know a square, all of its angles are right angles, right? So right angles here, as you can see here. So yeah, so you need to know that all of these sides are equal to 1, 1 each, okay, 1, 1, 1. And as for this triangle, very similar. This is an equilateral triangle. So memorize that this is an equilateral triangle, right? Equilateral triangle with a length of 2 here, and this side being 2 as well, and this side being 2 as well, okay? So this side is also 2. Okay, so memorize this. And then we know that all of these angles, right, what are all of these angles going to be? They're going to be equal. And we know the sum of the angles in a triangle is 180 degrees. So here, this is x, right? Let's say this is angle x. This will also be x because they're equal. This will also be x because all three angles are equal. So we know that x plus x plus x is going to give us 180 degrees. And x plus x plus x, what is that? That's basically 3x. So 3x is equal to 180 degrees. And then if we divide this by 3 to solve for x, right? Solving the equation, solving for an unknown, this will cancel and x will be equal to 60 degrees. So this will be 60 degrees, this will be 60 degrees, and so will this be 60 degrees. So 60 degrees, x is equal to 60 degrees here, and x here is also equal to 60 degrees. So now knowing that basically the only things you really need to memorize is this square and this triangle with the specific dimensions of 2 here, like this is also 2, right? All three of them being 2, and then all of these being 1, right? All of these being 1 unit long, okay? We can basically build our special triangles from here. And also, we can basically find our trig ratios from here. So let's build our special triangles. So to build the special triangle, I must basically split this square right here, to like draw a diagonal line. Also split this triangle right here, just like this, okay? So we have 2 triangles right here. So 1 triangle here and another triangle here, another triangle here, and another triangle here. So 2 triangles here, 2 triangles right here. So our focus should be on the specific triangle right here. So I'm going to highlight that. And for this triangle, our specific focus should be on one of these triangles. So let's say I'm going to highlight this one, and from these triangles we are going to have to basically find the angles and the sides. So if we look at this triangle, right, we see that the one here and the one here, these are the 2 legs of the triangle, and here we have the hypotenuse, okay? I'm labeling it as h. This diagonal line here is the hypotenuse. And we don't know what the hypotenuse is, and we're going to try to find that, okay? So we are basically trying to find all the sides of this triangle and all the angles of it. So first we're going to start with the hypotenuse. So to find the hypotenuse, we must recognize that this is a right angle triangle. This yellow highlighted triangle is a right angle triangle. And since it's a right angle triangle, we basically need to take these 2 legs, right? These 2 legs, we need to square each of them, okay? And we can use the Pythagorean theorem. We square each of them, and we can also square this one as well, the h, right? Hypotenuse, we square that. So this is the Pythagorean theorem. And so from here we can solve for h. So here it's 1 squared plus 1 squared. 1 squared is equal to 1. Another 1 squared is equal to 1 as well. And then all this is equal to h squared. So 1 plus 1 is equal to 2. And here it's h squared. So h squared is equal to 2. And since that's the case, we know here it's squared and the opposite of that is square root. So I'm going to square root both sides. And the square root and the square cancel. So this is going to leave us with h. And this is square root 2. So h is basically equal to the square root of 2, just like that. So here we can write that h is equal to square root of 2. Now to solve for the angles in this right angle triangle, we already know this is 90 degrees, right? It's a right angle. We don't know this angle yet, and we don't know this angle, but we can recognize that this yellow triangle is an isosceles triangle, right? So isosceles triangle, so this angle here is going to be equal to this angle here, since this side here, right, is equal in length to this side. So it's an isosceles triangle, so that means these angles that I recently drew in are equal. So we can label each of them with the same letter A, and what we're going to do is we're going to add this A with the 90 degrees, and we are going to recognize that the sum of these angles, right, is going to be 180 degrees, because the sum of the angles in a triangle adds up to be 180 degrees. So I'm going to do that. So A plus 90 degrees basically gives 180 degrees. So here we have A plus A. A plus A is basically equal to 2A. Here we have 90 degrees. So going to add that. And then here this is all equal to 180 degrees. Okay? And so we can solve for A, and to do that we can subtract 90 degrees from both sides, so we can move this 90 degrees to the other side. So subtracting both sides by 90 degrees, we get this, right? So you're solving equations. So I did this on both sides, subtracting 90 degrees on both sides, and cross this out, it gives 0, right? 90 minus 90 is 0. So we're left with 2A is equal to 90 degrees, right? Because 180 degrees minus 90 degrees gives 90 degrees. So here we have 2A equals 90 degrees, and this is 2 times A, so the opposite is going to be divide, so divide by 2 on both sides. This 2 cancels with this 2, and then A is going to be equal to 45 degrees, because 90 degrees divided by 2 is 45 degrees. Thus, this angle here is going to be 45 degrees, right? This angle here, okay? And then this angle here is going to be 45 degrees. So A is equal to 45 degrees, okay? 45 degrees here, 90 degrees here, and 45 degrees right here. So my angles for this triangle are the following. So I'm just going to circle these so it's nice and clear. So we have these 3 angles right here. So 45 degrees, 45 degrees, and 90 degrees. And we also have the side lengths 1, 1, and the hypotenuse of square root of 2. Alright, so now we are going to solve for this yellow highlighted triangle here. So it's also very important to note that this line I drew here, cutting the original equilateral triangle in half, is basically the perpendicular bisector, okay? So that means that this length right here, right, this length right here is going to be equal to this length right here. So this length right here is the same as this length right here. So this side right here is the same as this side right here. Okay, equal in length. And since it's a perpendicular bisector, there's a right angle, okay? So this would be 90 degrees. Now, we can basically solve for this triangle, okay? So one thing we can notice is that this side length right here and all the way here right? This whole thing is 2, right? So if this side here is going to be equal to this side here, well, what does that mean? Well, it basically means that one of these green highlights, right, that I did is going to be equal to 1 because we know 2 divided by 2 is going to be 1, right? There's 2 parts, 1, 2, right? So one of these parts is 1, and here this is also 1. So that means this side length of this triangle is going to be equal to 1. Okay, so this side is 1. And now we have a missing side right here. Let's call this side B, okay? So we're trying to find this side right here. It's also the height of the equilateral triangle, but we're mostly focusing on the yellow triangle right now, right? Just half of that triangle, like cut in half, right? Half of the equilateral triangle is the yellow triangle. So anyway, so we're trying to find this B, and we can focus and really see that we have 2 here and we have 1 here, right? And we can see, oh, well, this is a yellow triangle that is a right angle triangle, so we can use the Pythagorean theorem. So using the Pythagorean theorem, we can recognize that b squared plus 1 squared, right? These are the legs of the triangle, is going to be equal to 2 squared. So the hypotenuse, right? Squared. This is the hypotenuse, so hypotenuse squared. So b squared plus 1 squared is 1. Okay, 2 squared is 4. And then we can isolate for b, so b squared plus 1 minus 1 equals 4 minus 1. Okay, I'm subtracting 1 from both sides. It's going to cancel. B squared is thus equal to 3. And then square rooting both sides, we get b to be equal to square root of 3. So thus this b is going to be equal to square root of 3. So this side here is square root of 3 right here. So now we have basically found all 3 sides of this right angled triangle. Now we need to find the angles, right? We already know that this angle right here of this triangle is 60 degrees, okay? We know this angle here is 90 degrees, it's a right angle. Okay, so I'm gonna write that down. And then this angle here, we don't know, okay? This angle, however, like this one right here, we know is 60 degrees, okay? This here is 60 degrees, but we want to find this angle, okay? So this is the angle that we don't know. And how do we do that? Well, we can recognize that all the angles, the internal angles in the triangle add up to 180 degrees. So this angle here, let's call it y, okay? And so we know that angle y here plus 90 degrees plus 60 degrees will add up to be equal to 180 degrees. So I'm going to add them up. So y plus 90 degrees plus 60 degrees is going to give me 180 degrees. So y plus 90 plus 60 degrees, 90 plus 60 degrees is equal to 150 degrees. And that's going to give me 180 degrees. And then I can do this. I can subtract 150 degrees from both sides, like this. Okay, and then this will cancel. So I'm basically solving for y. So for y, I'm going to get 180 degrees minus 150 degrees. And that's basically equal to 30 degrees. So y is equal to 30 degrees. So this angle right here is thus 30 degrees. 30 degrees right here. So I'm just going to circle these angles right here. So 30 degrees. This is 90 degrees. This is 60 degrees right here. And so thus we have solved our triangle. So to find the special trig ratios, we see that this is 45 degrees, right? 45 degrees. We have 30 degrees and 60 degrees. We're not really going to look at 90 degrees. We're only looking at 45 degrees, 30 degrees, and 60 degrees, okay? So we're going to find the sine, cos, and tan. For 45 degrees, sine, cos, and tan for 30 degrees, sine, cos, and tan for 60 degrees. So firstly, looking at 45 degrees. So sine 45 degrees. So we know sine, right? Sine of some angle is going to be opposite over hypotenuse, okay? So opposite over hypotenuse. So if we look at sine 45 degrees, we will have it right here, right? This is the angle, so 45 degrees. So we're going to look at opposite over hypotenuse. So opposite, we look at this angle. What's opposite to this angle? Well, this side is going to be opposite to it, right? So this side right here, okay? So this side right here measures 1. So I'm going to write down that the opposite side is going to be 1, okay? So 1 over the hypotenuse. Hypotenuse is going to be square root of 2 because here h is equal to square root of 2, right? That's the longest side of the right angle triangle that's highlighted in yellow, okay? So we're looking at this triangle right here, yellow highlighted triangle. So this is the hypotenuse, so we write square root of 2 right here in the denominator. So thus we have sine 45 degrees. So now looking for cosine. So cosine, we know cosine theta is going to be adjacent over hypotenuse. So cosine 45 degrees we are looking for, right? 45 degrees is right here, okay? This angle right here, 45 degrees, okay? And we look for adjacent, okay? Adjacent side, so this angle is right beside the one right here, this side, okay? So adjacent is 1, and then hypotenuse is square root of 2, right? As shown in this yellow triangle. So this longest side is square root of 2. So thus we have cosine 45 degrees to be 1 over square root of 2. Now for tan 45 degrees. Now for tan 45 degrees, we need to look at tan theta, right? Tan theta is equal to opposite side over adjacent side in the right angle triangle. So tan 45 degrees, we look at the angle 45 degrees. We look at the opposite side, so it's this side, right? 1 here. So opposite is going to be 1. So we write 1 on top, right? From the formula, and adjacent is equal to 1 right here because this side is beside this angle, okay? So this is our adjacent side, this is our opposite side. So I'm going to write down 1 right here, and so this is going to be equal to 1. Well, a common question I also get is, well, this angle is also 45 degrees too. What if we apply the trig ratios from this angle? Okay, well, let's try sine. So sine 45 degrees. So looking at this angle right here, sine 45 degrees, this side is the opposite, right? So it's opposite. And for sine, we need to find opposite over hypotenuse, right? So here for sine 45 degrees using this angle, it would be this one here, it's opposite, so it'd be 1, right? So here it's also 1. And hypotenuse over hypotenuse, so square root of 2, so square root of 2 right here. As shown in the formula, so 1 over square root of 2, right? Because this is the hypotenuse. So there, we have the same thing, exact same thing. You get the exact same thing if you use this angle. For cosine, it's the exact same thing as well if we use this angle. So for cosine, we look at adjacent, so this side would be adjacent, right? This one would be adjacent, so 1, okay? Because the formula says adjacent, and hypotenuse would be this side, square root of 2. So this side would be hypotenuse h, right? So adjacent 1 over hypotenuse square root of 2. That's going to give the same thing for cosine 45 degrees. Doesn't matter as to whether we use this angle or this angle. Now how about for tangent, you may ask? How about tan of 45 degrees? Okay, so let's say we use this angle instead of this angle, right? Like we previously did before. Tangent, well, the opposite side is going to be 1, right? This is going to be the opposite side because it's opposite to the angle if you draw a line like that, right? And adjacent, right? We need to find opposite, and then we find adjacent. Adjacent is going to be this one here because it's right beside the angle. So opposite over adjacent, 1 over 1. Hey, exact same thing. 1 over 1 gives 1. So in conclusion, regardless as to whether we use this 45 degree angle or this 45 degree angle, we get the exact same ratios. So thus it is safe to say that it doesn't matter as to where we use this angle or this angle in determining these trig ratios. Because this angle right here and this angle right here, they are both 45 degrees. And we are trying to find for 45 degrees, so it doesn't matter as to where we use this angle or this angle. They are the exact same angles, they are both 45 degrees. Moving on to this triangle right here. So let's find sine of 30 degrees first. So sine of 30 degrees. Sine of 30 degrees, we look at 30 degrees here, right? And we can see that we need to find the opposite side, okay? The opposite side is going to be here, right? Opposite to this angle right here, right? So our opposite side is going to be 1 because this side measures 1. Okay, so this is opposite, and we need the opposite side because we need to find opposite over hypotenuse, as shown for sine theta. Now hypotenuse is this 2 right here. This side is the longest side, and it's opposite to the right angle, so that means this side is the hypotenuse. So our hypotenuse is going to be 2, so 1 over 2. Opposite 1 over hypotenuse 2. For opposite over hypotenuse for 30 degrees. Now, how about cosine of 30 degrees? Now, for cosine of 30 degrees, we look at this angle, right? This is 30 degrees, and we are trying to find the adjacent side over hypotenuse. So adjacent is the side right beside this angle that I just drew. So it's going to be square root of 3, right? This side is right beside this angle, so adjacent side is square root of 3. And then hypotenuse, right? Hypotenuse, adjacent over hypotenuse is going to be 2, just like before. So this is going to be hypotenuse 2. This is going to be adjacent. So adjacent over hypotenuse is square root 3 over 2, just like that. Now how about for tan 30 degrees? For tan 30 degrees, we need to look at opposite over adjacent for 30 degrees. So the opposite side is right here, right? It's going to be 1 as mentioned before, so opposite is 1, okay? Because it's opposite from 30 degrees, okay? You have to travel from here to here. And then adjacent side is right beside the angle, right? So what's right beside this angle? Well, it's going to be this side, okay? It's square root of 3. So square root of 3 is the adjacent side right here. So opposite over adjacent, opposite over adjacent. Perfect, okay? So here we have found tan 30 degrees. Now, how about for 60 degrees? So 60 degrees, we need to find sine 60 degrees. Sine 60 degrees, we will basically need to look at opposite side, which here in this case, we're looking at this angle instead, right? This angle, and opposite to that is this square root of 3. So we have our opposite side, square root of 3, as shown from here, square root of 3, and then hypotenuse is going to be 2, because it's the longest side in this right angle triangle, so hypotenuse, and opposite side like this, square root of 3 over hypotenuse of 2. So this is sine 60 degrees. Now for cosine 60 degrees, we basically look at adjacent side, right? Adjacent to this angle right here, and that's going to be 1, okay? Right beside this angle. So 1, right? Because adjacent over hypotenuse. So this one is the adjacent side. Hypotenuse is still 2, okay? It's the longest side of this triangle. It's opposite to the 90-degree angles. That's how the hypotenuse is. It's opposite of the 90-degree angle. So 2 is going to be the hypotenuse. So writing 2 right here. So adjacent of 1, right? Hypotenuse of 2, because this angle is right here. It's 60 degrees. 60 degrees is right beside this 1 adjacent, and the hypotenuse is the longest side, and the hypotenuse is supposed to be opposite to the 90-degree angle. Now lastly, for tan 60 degrees, we look at our opposite side over our adjacent side, and our opposite side in this case is square root of 3 because we're looking at 60 degrees, so opposite to that is square root of 3, square root of 3, and then adjacent side, and then adjacent side is right beside the angle here, right? So it's going to be the 1. So 1 right here is adjacent square root 3 over 1. Now, how do we simplify square root 3 over 1? Well, anything over 1 is just going to be the numerator, so we're just going to write square root of 3, and this thus is equal to square root of 3. Alright, so we have found our trig ratios. Now, another thing to note is that we can also rationalize the denominator for 1 over square root 2. So instead of writing sine 45 degrees is equal to 1 over square root 2, or cosine 45 degrees is equal to 1 over square root 2, we can basically rewrite this, right? Rewrite 1 over square root 2 differently, and how we do that is we can multiply the numerator and denominator, right? Both by square root of 2. So what does this do? Well, we can recognize that 1 times square root of 2 is going to be square root of 2. And our denominator, we have square root of 2 times square root of 2. Square root of 2 times square root of 2 is going to become the square root of 2 times 2. So we can combine the 2's right here inside the square root, all underneath one square root like this. And then we can see that this is square root of 2, right? And then this over here, 2 times 2 is the same as 2 squared. Okay, so 2 squared, and that's underneath the square root. And then we can see that from here, it's square root 2 over 2 squared with the square root, and the squared and the square root can cancel, right? So it just leaves us with 2. So thus we have square root 2 over 2. We can do the same thing for cos of 45 degrees, right? Because this number here is the same as this. They are both equal to 1 over square root 2. So we can say that this 1 over square root 2 is equal to square root 2 over 2 if we rationalize it. And here, this is also going to be square root 2 over 2 if we rationalize the denominator. Similarly, for tan 30 degrees, we can also rationalize the denominator for 1 over square root of 3, right? 1 over square root of 3, we have a square root in the denominator. We can also rewrite this. So 1 over square root of 3 is basically equal to the following. Well, if we multiply the numerator and denominator, we're making an equivalent fraction again. So it's not going to really change anything, right, in terms of its value. So here we are going to get square root 3 on top, right, because 1 times square root of 3 is equal to square root of 3, and then the denominator, we have square root of 3 times square root of 3, so that's going to be all underneath 1 square root, right? So we combine the square roots. So we combine the 3's together, all underneath the square root, because we have 2 square roots like that, and they're being multiplied together, so we can do that. So 3 times 3 underneath 1 square root. This is equal to square root of 3 in the numerator, denominator. 3 times 3 is equal to 3 squared, so 3 squared like that, okay? And it's all underneath 1 square root. So numerator is equal to square root of 3, so square root of 3. And the denominator, we have a square and a square root. Square and square root are opposite, so they cancel, so we will be left with 3, right? Because the square and the square root disappear because they cancel each other out, so this 3 is left. So thus we have square root 3 over 3. So this can also be rewritten as square root of 3 over 3, just like that. So here we have the angles and degrees, right? But what if you were asked to give your answers in radians? Well, we just have to convert these degrees to radians. So we have 45 degrees here, right? To convert 45 degrees to radians, all we have to do is write down 180 degrees underneath and the pi here, right? Because we want to get rid of the degrees, so we put the degrees unit underneath here, right? So it could cancel with this. So we have pi here, okay? And we want pi because we want radians. So here we are going to carry this out, and it's going to give us 45 pi over 180. And so we can divide the top and bottom by 45 to simplify it. And here we will basically get pi over 4. Pi over 4, 180 divided by 45 is 4, so we get pi over 4 here for 45 degrees. So thus we can conclude saying that sine of pi over 4 is basically equal to 1 over square root 2 equal to square root 2 over 2, and cos pi over 4 is equal to 1 over square root 2, which is equal to square root 2 over 2, and then we have tan pi over 4 is going to be equal to 1, right? Because same things as this, okay? So square root 2 over 2 right here, square root 2 over 2 copied right here, 1 copied right here, right? Because tan 45 degrees is the same as tan pi over 4, right? And cos pi over 4 is the same as cos 45 degrees. Sine 45 degrees is the same as sine pi over 4. So that's how we get these, okay? And then here we have 30 degrees. We can convert that. So 30 degrees times pi over 180 degrees. So the units we want to get rid of are degrees. So write the degrees in the denominator. Now we can basically divide by 30 in the top and bottom. Dividing 30 in the top, we are going to get 1. Dividing 30 in the bottom, 180 divided by 30 gives 6. So I'm going to write 6 right here. So thus this is equal to pi over 6, okay? Pi over 6, 30 degrees is going to give pi over 6 in radians. So sine pi over 6, just going to copy these, 1 over 2. Cos pi over 6 is equal to square root 3 over 2. And tan pi over 6 is equal to square root 3 over 3, which is equal to 1 over square root 3, depending on which one you want to write. So there we have it for pi over 6, which is for 30 degrees in radians. Now how about for 60 degrees? Now 60 degrees, same thing, so 60 degrees times pi over 180 degrees. So dividing the top by 60 degrees, dividing the denominator by 60 degrees, we get 3 in the denominator. So we can say that 60 degrees is equal to pi over 3, and pi over 3 is basically 60 degrees in radians. So sine pi over 3, right, is going to give square root 3 over 2. Cos pi over 3 is going to give 1 over 2. And lastly, tan pi over 3 is going to give square root 3, as shown right here. So there we have it. We have found all our trig ratios, right? All simply by manipulating with these diagrams. So remember, the only two things you really need to remember in order to construct these diagrams, those ratios, right? Is just the fact that we have a square here that has sides all measuring 1, okay? All of these are 1, and an equilateral triangle with all of these sides measuring 2. Okay, so memorizing that, you can basically construct these diagrams right here, from which we can basically find the unknown sides and the unknown angles for the triangles. And then after finding all this information, you can basically find the trig ratios for these special angles right here for 45 degrees, 30 degrees, and 60 degrees. So you don't actually need to memorize them, you know what I mean, like repeating them, regurgitating them over and over again. You can instead build them, and so it will save you time from having to relentlessly sit there and try to memorize exactly which one is which. And besides, even if you build it, once you get used to it, you will automatically memorize it. You don't have to go through the pain, the agony of sitting there trying to memorize, oh, what is sine 60 degrees again? Instead, you can just build it all out. Of course, you may think it takes a long time because this video did take a while for me to build this out, but of course, it's because I am showing you how it works for the first time. But once you get the hang of it, it is very, very, very quick. You just build these diagrams and figure out what these trig ratios are going to be. Alright guys, so this brings me to the end of my YouTube video. Thank you for watching. I hope this video helped. If so, feel free to give it a huge thumbs up. And of course, feel free to let me know on your thoughts in the comments down below. And if you are new to my channel, don't forget to subscribe. Alright guys, I hope to see you next time for another math video. Bye!